This unit, we are still working with lines, and more specifically, we're going to focus on that slope-intercept form. So in the last section, we worked a little bit with transforming equations to put them in slope-intercept form. Now we're actually going to graph those lines using our knowledge of slope-intercept form. So we know in that y equals mx plus b equation that m represents our slope, how far up and how far across we have to go, rise over run. Now we're bringing in our new friend, b. And b is defined as our y-intercept. Let's talk about that term for a second. The definition of a y-intercept is where a graph crosses the y-axis. It's where a graph crosses the y-axis. One thing that we do know with respect to our y-axis is that you can look at any ordered pair on there, your x is always 0. So we are going to use this information, folks, to start plotting a couple of points and graphing our lines. So let's start with a couple of examples. So let's look at the first example. We're given y equals 1/2 x minus 5. So we can identify for this equation, our m is 1/2. We can also see that our b is -5 because this graph is going to cross the y-axis at y equals -5. And we know this because if we plugged in 0 for x, that term would go away. And we would have, when x is 0, our y is -5. So here is how we start our graphs. We start with b. We know that point to be on the graph, 0, -5. You'll notice I put my -5 point on my axis. And now we're going to use our knowledge of m. I know that my rise over run is 1/2. My rise over run is 1/2. So here's what we can do. That means starting at this point that we know is on that graph, we can go up 1, rise, up 1, run over 2. So I'm going to delete the mess so it's clear. We went up 1 over 2. I can do this a couple of other times. I can go up 1 and over 2. And we can do this as many times as we'd like until we see the pattern that our line is forming. I want to relay to you something that is sometimes useful, but in this case, we didn't really need it. I know that 1/2 is also -1 over -2. So sometimes if you need more space on your graph, we could also, since these two are the same, we could also go down 1 and to the left 2. And that point would also be on my line. And then the last thing we need to do, folks, is connect the dots. And we've got our line. Let's look at this example. We have y equals -2/3 x plus 2. Let's identify the m and the b. So our m is -2/3 and our b is 2. Here is one thing that I also want you to appreciate. I can treat m as -2 over 3 or 2 over -3. Those are both ways of saying -2/3. So I can work with either one of those ratios for my m, but we always start with b. It even comes before m in the alphabet. We notice that the b is 2. That's our y-intercept. Remember, that's the same thing as saying when x is 0, y, the y-intercept, b, is 2. So we start by plotting the point 0, 2. Once we've plotted 0, 2, now we're going to go to the m. Our m is, I'm going to start with 2 over negative 3. I would go with that boxed m. I would rise 2 and then go to the left 3. So I would go up 2 and 1, 2, 3 to the left. And I can do that a couple of times. Rise 2 to the left, 2, 3. What if I chose negative 2/3 instead? So let's look at what happens if I plotted with my blue negative 2/3 ratio. When we see that, I'm hoping that you recognize that would be down 2 and to the right 3. So I would still start at my yellow starting point and go down 2 and to the right 2, 3. And my hope is that you can see that points plotted, we only really need 2. But this gives us affirmation that we definitely see that linear trend. So then we can plot our line and we are set. So I wanted to quickly show you the one thing that is a little bit different in this one is that our m is negative 4 and our b is 9. When you are plotting using slope-intercept form, it is super helpful to have your m look like a fraction. So we can see here, we would just write that as negative 4 over 1. And then business as usual. We would start with our b, and that b is 9. So we'd plot the point 0, 9. That's my y-intercept. And then if I look at that as negative 4 over 1, so now we would go down 2, 3, 4, and to the right 1. Down 4 and to the right 1. And we would finish our line. So our steps are find that y-intercept, find your b, and then use your m to figure out the rise and the run. Let's look at one that's not in our slope-intercept form. We'll see in question 5, we have this line, negative 2x minus 4y equals negative 4. So we're going to need to write that so that it's in our slope-intercept form. We've done this before. We have practice. So here we're going to get y by itself. So we would add 2x to both sides, leaving us with negative 4y equals 2x minus 4. And now I still want to get y alone, so I'm going to divide everything by negative 4. So it looks like this. And now we just clean that up. And we still have a little step to go, but you'll notice here a couple of things. One is that we had negative 4 over negative 4. A negative divided by a negative gave us positive 1. So the last thing that we need to do is just reduce negative 2/4. And we have y equals negative 1/2 x plus 1. And with that, we can identify m and b. And so now we can plot this. We've got our b, that's 1, that's the y-intercept. So I'm going to start my graph at the point 0, 1, and m is negative 1/2. So we can go down 1, that's negative 1, and to the right 2. Down 1, and to the right 2. And if we felt inclined, we could also treat that as 1 over negative 2, meaning I could go up 1 and 2 to the left. And then we can see the pattern of our line. Last, we would just construct our line. Our last special case is working with horizontal and vertical lines. You'll remember that for horizontal lines, our slope is 0. any horizontal line can be written in the form y equals b. You'll notice that x is not present in that equation. And it's because your m is 0. It abolishes the x. X goes away. It's being multiplied by 0. So we would just plot the line y equals b. B is a constant, so it could be y equals 3, y equals negative 12. And remember, that's going to be a horizontal line that's going to cross through whatever that b value is. Let's do an example of that. So here we see, for this problem, y equals 5. So that means x can be anything it wants, but y has to be 5. So x could be 0, 0, 5. X could be 2, y has to be 5. X could be 6, well, y has to be 5. You are getting the point. So then we can see, oh, that's a big arrow. And that line would be the horizontal line y equals 5. Now with vertical lines, you'll recall that our slope is undefined. And that's also because a vertical line is not a function. So that always follows the form x equals some constant a. So it is the reverse of what we worked with our y equals b. That means now y can be anything it wants, but x is going to be that value a. So a vertical line will look like x equals 3, x equals negative 5. We'll do an example. If we saw this graph, x equals negative 2, we know for certain that that's a vertical line. That means y can be whatever it wants, but x has to be negative 2. So we could start with y could be 0. Well, x is going to be negative 2. Y can be 7, but x is still going to be negative 2. Y could be 1. X is negative 2. Y could be negative 3. We see the pattern, and we knew this was a vertical line anyway. And we're set.